And my name is Toshifumi Kunimoto. Came from YAMAHA, Japan, to introduce you some ideas about DSP application. Before that, thank you very much for the introduction of myself, Wojciech Sensei. But I was afraid that the Wojciech Sensei talked many things of my topic, so maybe nothing have to introduce by myself today, but still something remain. And please excuse me, just a minor correction on the Wojciech Sensei's introduction of mine. It was, this is the article I wrote in a rock magazine 40 years ago. It's a Japanese thing, so, but it's not a review of the guitar stomper. Actually, how to make guitar stompers. Sorry. And it was my pastime job in my university students' days. So today's agenda, I make some musical instruments or audio gears in YAMAHA. Actually, I worked for the technology side of the products, mainly. And some products, I was a planner. And anyway, this is the representative of my works in YAMAHA during this 35 years. And first one, the V1, then EX5, SAD, then last one is the Reverge PM10. It's a digital mixing console. Okay, dive into the precise discussion. V1 was the first physical modeling synthesizer in a commercial base. We have released it in 1993, the year. Virtual acoustic synthesizer is a technology name we introduced in those days. It's equal to physical modeling of the musical instruments. And when we introduced the idea of the physical modeling or virtual acoustic synthesizer to the conventional people, it was very tough. So we made these pictures to introduce the idea of the physical modeling on the musical instruments. So this chart, like animation or manga, introduced the idea of using a metaphor of the acoustic musical instrument like a human, Above 3 types of musical synthesis methods. Above means the conventional synthesizer like analog synthesis or FM, or wave memory synthesis, or virtual acoustic synthesis. These 3 are explained on below. So, mouse cursor, yes, this one look like a robot. So conventional music synthesis like analog synthesizer is resembled to robot. Can talk and can walk and can move like human, but does not look like human at all. And the next one, this guy, wave memory synthesis is similar to an idea of a movie. At a glance, it looks very realistic, but always behaves the same, and the controllability is bad. So it needs various pictures of a smile face, or a serious face, or anger face, or a crying face, or it's a necessity. Then, third one, virtual acoustic synthesis, physical modeling of the music instruments is kind of an android. He can talk, work, and move. So controllability is very good, and it looks very real. This is a concept of the physical modeling music synthesis. And when we talk about the physical modeling of the musical instruments, it consists of 2 elements, approximation of linear system and approximation of nonlinear system. So nonlinear system, too much for today, so I will skip this presentation chart, then go to the linear system, like a pipe and a string immersion. Wave propagation and the pipe or string is very much similar, and we can emulate those kind of phenomena in the DSP code software. Realization of fair horn is DSP consuming. That is very big program. big problem for us, a big problem for DSP guys, any of DSP guys. And the conical horn can be approximated by straight horn using acoustic theory. This is a theory and a paper I discovered in those days. I will show you more precise theory. This is a conical horn, like a saxophone or oboe bassoon. It should be emulated in DSP domain like this. Should be divided into many cylindrical emulation in the digital domain, because digital is discrete, analog is continuous. So analog should be emulated in DSP domain using quantization. This is the result. So as a result, we must do every single cylinders by digital filter. Means that 100, 200, 300 digital filter should be implemented into the one DSP chip. It's crazy idea and very tough to get. Very DSP intensive application, it is. But in one theory, I discovered a paper that described that straight horn can be replaced acoustically, the conical horn in acoustical approximation theory. This was made by Saneo sensei. He was a very big father of the Kyushu Institute of Technology. Then he made this theory on the 1977. I discovered this paper in 1987, then became aware straight horn can replace the conical horn, or string also can replace a conical horn. It means that recorder straight pipe can replace a saxophone conical horn, or oboe conical horn. Very interesting, very interesting. And the same kind of model can be utilized for the violin immersion. This is also very important. So when I made VL1, so VL1 can be not only a saxophone, but also the trumpet, like a brass timbres musical instruments, also like a violin. So this lecture, I will show you an idea what kind of DSP technology can contribute to the actual product of Yamaha. So I constantly tell you pros and cons of the individual products. Pros of the virtual acoustic synthesizer VL1 was first music synthesizer employed physical modeling idea, and the exact behavior and real sound of the musical instrument in reality was achieved. Cons, keyboardist hates breath controller because spits. It's not so healthy for the keyboardist. It's reality. Very few percentage of people love to use breath controller, but the rest of the people hate it. Chick Corea was an exception guy. And difficult to play like real acoustic instruments. Also, this is the cons. Real musical instruments, you need training when you want to play good music. So virtual acoustic synthesizer, you need to train. You need to be trained, so to speak. This is reality. And not so big demand on pipe instrument sounds among keyboardists. Keyboardists constantly want to play piano synthesizer sound, or string sound, blah, 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 you know. So demand of the pipe instrument sound was small comparably to the other sound. So, and also, virtual acoustic synthesis, physical modeling is very mathematical and acoustic problem, so big development time and the cost were demanded, you know. So business so-so, but the development cost is very big. It was reality on the virtual acoustic synthesizer age. But we are now making derivative of the VL idea. Straight horn having a L1 and L2 length can be emulated through the straight form. And this is equal to branched pipe. Above chart and below chart, same in acoustically. Then we make actual musical instrument product. This. L1 here and L2 here. It's shorter, it's longer, mean that's flare horn. And it sounds like saxophone in this case. That's all I can play for you, because I'm not a good player. I'm not a real instrument player, so I cannot demonstrate. Anyway, this is just around $100 products we are now releasing onto the market. This is spring, summer, maybe June, we will start the releasing of these products onto the market. You can buy. Anyway, another one, EX5. So I must rush this topic because the time is consuming. So anyway, it's a workstation synthesizer we have released 1998. We put a lot of the synthesis method into one product like this. So summarize workstation products. And the EX5, we put many synthesis methods like VA1 or virtual analog synthesizer and FDSP, including other physical modeling ideas and FM ideas, and wave memory synthesis through sampling capability, and with memory expandability too, many things put into the one product. So maybe our customer also very happy to know, very happy to have, but many things happened. Pros was many types of modeling synthesis available with wave memory synthesizer, very good things, but lack of DSP power caused some problem. So DSP power is limited, so you introduce VA1 sound, you play, but you have to thrash virtual analog things. When you put the virtual analog things onto the DSP chip, so you have to thrash the virtual acoustic sound, or FDSP introduce, you have to thrash analog things, you know. DSP is limited, so it's a little bit complicated. And the user interface also, many things have to be controlled through the very simple user interface. Actually, it's too much for the user interface software organization. And many of the synthesis methods introduced mean that developing time and cost were enormous, so to speak. So, but the business was good for us, so it's very, tough to tell you what it was good products or not. So it was good products, but the developing time cost was very high. Still, that kind of problem happened in those days. So S80 we have released in 1999. It was piano synthesizer product, very simple. Conventional synthesizer having a piano keyboard, 88 piano keyboard, and a very good piano sound. That was a very good description of the S80. I'm sorry, this is not the C plan, S80 actually. Great investigation of the piano, acoustic piano, and the electric piano sound was done in these days. So to get the right sound for the piano synthesizer. So pros was great piano, electric piano sounds with good bread and butter sounds. It was possible on the simple S80 piano synthesizer. Yamaha has great reputation on the piano because we are a piano industry, basically. So piano, because we have been producing great acoustic piano many years, so Yamaha has good reputation. So, and also the small development time and cost was achieved because basic synthesis is just a wave memory synthesis. We have great contents and introduce piano sound, introduce piano good, very, very good piano keyboard. That's all we have done. Very good. Cons. Tough to find cons. Only wave memory synthesizer. No one cares about it. No one cares. Because the customers of this product is pianist rather than the synthesist. And a small flat display, it knows actually cons. Because many of the customers do only a program change play. That's all they do on these products. So small display is not a big issue for our customers. On the case of the SAT, then Motif days came. 2001, we have released first generation of Motif. Then we go to the Motif Motif ES and Motif XF and the Motif XS finally. 4 generations of Motif we have done. But the basic signal processing and sounding engine were always the same all through the Motif series workstation synthesizer. Like this. Just simple wave memory synthesis on Motif was introduced to the original revision and go to the final revision. And the effect system also very nicely organized. Insertion effect for every channel and send and return effects and master equalizer. That's all. And this is very essential when you see the block diagram representation of any of the mixing consoles. So it is based on the mixing console structure. So pros and cons of the Motif series. Thorough market research before product plan was a very key issue when thinking about this kind of the market-driven products. And the great sounds were introduced. Good user interface was well done, and good balance between development cost and the product performance was achieved. Cons, very tough to find the cons in the case of the Motif. Less algorithm than EX5. It could be a problem for some part of the customers, but and finally we knew that that's just only the sounding capability of the wave memory synthesis with some expandability was good for normal customers. But finally, we came up with the idea that FM synthesis like DX7 can be introduced again because nowadays the large scale IC develop the very big equivalent amount of the transistor, 1 million, 2 million transistors can be installed with one chip. So it means that we can introduce FM capability to the one chip very easily nowadays. So we introduced actually, and we have released Montage last year. What is VCM? VCM is the abbreviation of the virtual circuitry modeling. I'm talking about the introduction of VCM because later products constantly use the technology of the VCM. It's a physical modeling analog circuitry, means that individual equipments or individual musical instrument, everybody has individual circuit diagram. We have to emulate that when we talk about the very strict emulation of the sound of the original equipments or similar sounding of the referenced equipments. Some of them usually are the tube, bulb tubes, or some of them transistor, and in many cases the circuit diagram of the musical instruments or studio equipment has a very tricky things, tricky circuit diagram, a tricky way of the transistor can use for the variable resistance or many things happen. I don't know why, but it's a reality. So we have to take care and emulate very efficient way. This is the task we have. So in many cases, but fortunately, in many cases, the very standard S domain to Z domain conversion using the Z conversion, bilinear Z conversion, blah, blah, blah. That kind of the math can maintain the analog domain transfer function into the digital domain transfer function very easily. In many, not so many, but the rare cases, the sounding on the very high frequency, like near to the Nyquist frequency, cause some minor problem. We have to fix that, but still the problem is very simple. So we call it as a macro behavior modeling, macro modeling behavior emulation can be done in a so-so efforts. But in some cases, we have to dive into the more precise simulation of the components, like a transistor or field effect transistor or tubes or opt device kind of things. So any of the components, like resistor or inductance in this chart and the transistor, everybody has an individual equation. So equation can be translated into the DSP code. So if it's necessary, we dive into the individual component emulation using equation described in the DSP domain. Then I can show you some very easy to understand example. So this is the chart. You can see the frequency response to the guitar amplifier. I can't tell you what was the target on this case, but it is this blue line here, right-hand side. Blue line shows the one particular guitar amplifier's sound response from the input to no. In this case, it was from the output of the amplifier to the microphone. Means that there's a air transmission and the speaker magnitude response there. So blue line is very much complicated, very, very precise structure they have. And my filter, I described it in my doctoral thesis, can emulate like this, red wine, not red wine. I will get that later today. But anyway, red line can track the sound response with the original guitar amplifier speakers with cabinet. It is actually, I use the 16th order IIR digital filter. Okay, this might be good for today. So when think about the guitar amplifier representation in the DSP domain, we must take care about the amplifier response and the speaker response and the air distance emulation. So the everything has done on the single box in this case. So input of the guitar as a guitar sound. Raise loudness, please. Okay. Then go to the emulation using DSP technology. Okay. So this result came from the distortion emulation of the amplifier and the sound response emulation of the speaker and its transverse to the microphone. This is very exact. Then the sounds like rock. you know. Okay. Okay, another example I can show you later. Okay, then so DSP can make musical sounds using frequency response simulation and non-linearity emulation like distortion and saturation. And the gain behavior is another difficult issue when we talk about compression or dynamic control. Today, if I talk it, so it's too much, so I will stress that. Anyway, these are things we do precisely and extensively with virtual circuitry modeling technology of YAMAHA. So, next, my son. In 2009, we released CP1, electric piano, flagship. Again, we investigated a lot about every electric piano, like Rose and Wurlitzer and Yamaha CP and Yamaha DX7. So it's too much. So anyway, for the case of the Rose or Wurlitzer, how time vibration can generate the voltage of the magnetic pickup is very difficult issue because when thinking about this kind of relationship with the time vibration, the magnetic pickup electricity, they have a big nonlinearity using a Euclid theorem. So the nonlinearity has big influence onto the timbre of the electric piano. We have to emulate that. So this is the actual plot of the Rose sounds from 0 millisecond to 400 milliseconds. Start with the big harmonic contents on the attack portion, but goes to the almost sinusoid on the last part. So this is real sound. I can show you the sound example. This is the Rose sound. And this is the frequency magnitude response or spectrum, so to speak. You can see on the, for example, audio precision. And the attack sound, we have to decompose the original signal into the several components to achieve the individual mode frequency of the time. You know, time is a mechanism that have many of the resonance frequency it has. So we have to take care about the mode frequencies, then divide into the mode this and mode another this, you know. So divide into, in this case, 2 mode components like this. This is this might be very easy to understand. This is main mode frequency of the time of the electric piano, and the other component. And we make several components. First, the resonance to taking care about the mode frequency combination in the acoustic field. So finally we can get very good sounds of the Rose sound and the Wurlitzer sound and the CP80 also. And this is the aspects of the acoustic phenomenon you can see on the Wurlitzer or CP80 or Fender Rhodes. But the other part of these kind of electric gears, they have individual circuit diagram like this. Individual circuit diagram has an individual sound response. Actually, they are the results. This is the example of the some generation of the Fender Rhodes equalizer on the preamplifier. Individually, they have individual response, very different. They are actually. It is early 70s Rhodes. It's mid 70s Rhodes. It is early 80s Rhodes. Very different. So we can emulate. We know the response, we know the transfer functions, so we can emulate the response. So pros and cons. Finally, we get very good emulation sound of this any type of electric piano on CP1. The pros was good product plan as flagship EP and great DSP technology and great sounds. Technology hidden behind the panel. This is I think this is very important. Technology sometimes should be hidden behind the panel. Inherent synthesis was okay. Go to the cons first. CP1 was a flagship piano for Yamaha, so the price was around $5,000. I bought, but I'm exceptional also. So professional guy can buy $5,000, but usual people cannot buy. So business-wise, it's not so good, but the CP1's engine can be inherited to the another lower price range products or mid-price range products, like this. It is CP, but called reface CP. Okay, I can show you the power of the DSP. Example, it's a naked sound. Then apply wow using virtual circuitry emulation technology. Warm punchy came from the VCM technology, but still I have a small frustration on that immersion sound. We need more distortion. We need more. Oh, very good. That's it. Another example, road sound, I love. And this is naked sound. So when you think about this kind of age of the vintage stuff, maybe this kind of effect was necessary. Very warm. This is VCM, okay? So sound range is very much in line with the cheapy ones, but it's a lower price range product like a 500, so a little bit, less expensive. Anyway, so go to the another product, digital mixing console, Reverge. This guy, we have released last year, equipped a lot of VCM technology, not only channel strip, but also the plug-in effects and the equalizer, compressors, they have done using VCM technology. My team contributions many ways. DSP architecture I made, general purpose DSP for plug-in effects I introduced, and the plug-in audio effect development my team has done using VCM technology, and the third-party collaboration with reporting design and TC. So, virtual circuit modeling family, I can show you those kind of things introduced 10 years ago to the digital consoles. They are the very good audio effects or channel strip ideas, but no brand. It's a key issue. Branding is very important in this world. Sounding very well, not enough. Brand also should be included. So we talked with the Reporting Eve Design Corporation, and then we decided to move to the Reporting Eve compression or Reporting Eve equalizers should be included on the variation of the plugin effect for the reverse PM10. So those 4 gears are very big, because we collaborated with Reporting Eve himself. I am maybe 20% or 30% guys knows about the Reporting Eve, but the other guys do not. But Reporting is a true legend of the pro audio industry. His equalizer he has designed many years ago is very, very, expensive right now, still right now. So we have introduced this kind of, VCM audio effects plugins into the reverse PM10. So it's very successful products, but the price is very gorgeous, like $200,000 or something like that. It's top end, so. Digital mixing console reverse PM10 pros and cons. Pros was thorough market research and product plan, and great DSP technology and great sounds. And great product stability, also the key issue when we talk about the Yamaha's products. And a great capability like expandability and modularity. And the cons, very tough to find the cons on these products. So I will go to the summary of this presentation lecture. So turning point, I think you can understand very easily. Turning point for me was between the EX5 and the S80. Because the EX5, we introduced lots of technology, but business-wise, business was good, but the ratio between the development cost of the business was bad. But S80, much better. Business is good, development cost was lower, customer very happy to have that. So reasons. There is a positive correlation between technology and the business gained by a product. But technology itself is not a necessary and a sufficient condition for a good business and good products. Important to have a calm recognition of the difference between the technology and the value you can supply to customers. It is very important. Keep cool. So I can imagine several approaches for the idea of the, when you think about your technology and application, your technology and a dreaming product, or your technology and a good business. First idea, great technology idea. If you think of great technology idea, then look for application. This is a technology-driven way. Some cases may be workable, then in many cases, very tough. Second idea, great product idea first. Then you look for technology for your product idea. It's called sometimes open innovation or something like that. But it's also the difficult way to make great products. Third idea, current my thinking approach. Prepare basic technology first, then look for a great product idea or great branding idea or great collaboration idea. Then investigate more to have great products. I'm taking this way right now. This is the things I want to tell you today. Basically. Okay. Thank you for serious listening. Okay. Thank you. So I want to stress one thing today, information for students. we Yamaha has internship program. Some ideas organized by project sensei. Thank you very much. And product design division and the research and the development division both has an internship program. So in the product design division, you will have a position of the acoustic musical instrument design or digital music instruments design or network communication device design position. And the research and development division is my section, has two kind of area, acoustic area or digital signal processing area. And the spatial acoustic area also maintained. So, but unfortunately, this is the year end. November is too late for the next year. So the next year, fall of the next year, the next year will be maintained. So please send me a CV or something. Anyway, there is a chance to have an internship program in Japan. We pay you a work and you have an experience in our laboratory or design office 2 or 3 months, and around summer or fall, it's okay. Please. Then